in Rn, if m is less than n, then the span of the set V1 through V sub m doesn't include every vector in Rn. Okay? It can't. You need n of these things, at least n of these things, to span Rn. And if the set isn't linearly independent, you might need more. So we want to think about that and what it means. Okay? I'm going to say consider an arbitrary column vector in Rn. Okay? It's in the span if and only if C1 V1 plus CM VM equals this. For some set of vectors C1 through Cm. Okay? And what does that mean? I keep writing fast, we'll deal with it. Okay, well that means that means this, right? And that's xn, not xm. Well, then this matrix will have how many rows? N rows.
Yeah.
Because every one of your V1 through Vn's is in Rn, right?
Right.
Or Vm is in Rn. It's going to have n rows. How many columns? N rows. How many columns is it going to have? M columns, right? And m is less than n. This matrix is going to be longer this way than it is this way. What's that tell you about solutions?
It's not square, so it can't be.
I'm sorry?
It's not square, so it can't be invertible, so it doesn't have.
Yeah, it's not invertible. So what are you going to do to get a handle on what this matrix equation is going to give you? Well, if it's not an invertible matrix, then you're probably going to represent it as an augmented matrix, right? So I've got a little space here, and I'm going to use it because I'm going to run out of space here for too long. It'll cause a little bit of a disruption. So you'd solve this equation with an augmented matrix, right? And it might be like that's M1, not 1N. Okay? Make sense? And it's an augmented matrix, so I guess I better write down the augmented part.
Is that Vn to Vm and then V1 to Vn? What's
It's
the
not
bottom
raised to a
one?
power, so don't say to the M or to the M. It's sub M or sub N.
Okay.
Because you can confuse yourself. So, yeah, it's V11
Okay.
down through, I can't even read that, it looks like an M. It's an N1.
Okay, N1, okay.
Yeah, because remember, the first subscript is the number of your row, the second subscript is the number of your column, right?
Okay.
So the rows go from 1 to N, and the columns go from 1 to M. Okay?
All right, and finally, last one here.
And there's more statement I should have written. We get this, we get this. X1 through Xn is in the span if this has a solution. Okay? Now, I don't have room to write in what I should have here, but I'll say
Well, great, I'm sorry.
this is in the span if and only if we have a solution. Okay? Now, what are we solving for? We're solving for C1 through Cm, right? So this first column is coefficients of C1. The second column is coefficients of C2 and so forth. In other words, we're representing this system as an augmented matrix, okay? Okay, what's going to happen when we reduce this augmented matrix? Are we always going to get a solution?